All right, y'all. So like I said, 2.3 deals with finding the domain and range. All right, let me get one in real quick. Hell. All righty. So 2.3, finding domain and range. So I'll describe it. Now we're looking at domain of a graph in this section. So when we're looking at the domain of a graph, the domain is what we call the set of all x values. Which means our range will be the set of all y values. So y'all are going to give us some graphs to look at for the first two. And on these first two problems, they're going to give us a graph and we're going to find the domain. We'll find the range, and then we'll look at finding some function values they give us. So let us start number one here. So my first graph, I've got some points they're using. I got a point over here at -1, 1, 0, 2, 1, 3, and then 2, 4. All right, so 4 points going up to the right here. Now let me see if I can add some color to them to make them stand out a little more. All right, now to the left, I got a few points. I got a point at -2, 2, -3, 3, and then -4, 4. So y'all basically a V-shaped graph here consisting of these 7 points. So they're going to ask us 4 things on this. So for part A, they want us to find f of a -3. So y'all, when they give you function notation with a -3, remember, if they put a -3 in place of the x, they're giving you the x value. So what f of -3 wants us to find, what y value has a x value of -3. Okay, so that's basically what they mean by f of -3. So what we're going to do, we're going to come up here to the graph. We're going to come over here and find -3 on that x-axis. And at -3, we're going to go straight up till we hit that point. So y'all, what we want to know is what's the y value of that point?
3.
3. Perfect. So then B on this question, they want to know the domain. And y'all, they're going to give you the little x set notation. So they'll give you the parentheses. We just got to put, remember the domain we said was the set of all x values. So I'm just going to go right, left to right and put all these x values down and be done. So my first point, go straight down, has an x value -4. Second point, go straight down, has an x value of -3. And notice I got 7 points, so I'm going to need 7 x values in here. So y'all, next one is at -2, -1, I got a point here. Remember, if it's in an intersection, that x value is 0. Right at this point, if I go down, the x value is 1. And then my last point, if I go down, x value is a positive 2. So y'all, you're just going to put in the x values and separate them with those commas, okay? So y'all, part C of this is the opposite of part A. For C, they want any x values for which f of x equals 2. And then they'll have the answer blank, x equals, and then you put in whatever your answer is. And y'all remember this. They're giving me the y value. Remember, f of x is the same notation as a y. But we use this notation when it's an actual function. So they're giving me a y value of 2. So y'all, what x values have a y value of 2 on this graph?
-2 and 0.
All right, because look, here's 2, right? Perfect. You come down from that point, you're at -2. And y'all, the second point right here is sitting on the 0. Good job. Oh, so they'll come in there and you'll put your 0. And y'all, you're done, right? So part D. Let me pull this down just a little bit more. So part D, they want the range. And y'all, they'll have these little set brackets again. And all we're going to do is put our y values. Now, usually when I do y values, I go from the bottom up. So y'all, my smallest y value would be what?
1.
Perfect. And then as we go up to y's, well, I got 2 points at 2, but we don't have to put it in our range but one time. Putting a 2 in here covers both of those. All right, continuing up, the next y values look what, 3? And then finally, these last points have a y value of 4. So remember, my domain's coming off the x's. My range is going to come off those y values. All right, y'all. So for our number 2 here, for number 2, they're giving us a graph with lines on it. So y'all, I'm going to start my first point right here at 5, 0 on the x-axis. And let's see, it goes to this point. Well, it looks like I'm starting at 4, it looks like. 1, 2, 3. No, I'm at 5. So at 5, you got a point right here at 6, 1 it's going to go through. On the left side, it goes up here at 4, 1. All right, it's crossing the x-axis, the y-axis over here at about 5. So y'all, let me try to draw this line. It's got a line coming up to the right. And then this line sort of comes up through this point, up through that 4, and heads up that way. So let me color this in just a little. On the left side, a little curvy because I don't have a ruler. That's why we like rulers when we graph. All right, y'all, so there's our graph. So let's see, they're going to ask us the same 4 type questions. So for my first question, they want to know what is f of 2. So remember, they're giving me the x value of 2. So I'm looking for the y value that has an x value of 2. So what y'all think?
3.
3.
So let's see. Here's 2. I pop up, and yeah, it's pretty. My line's a little crooked, but y'all are perfect. It's definitely going to be 3. All right. So knowing that, we want the domain. Now y'all think about this. This line's going forever to the right. This line's going forever to the left. So it looks like my x's are going to cover everything out this negative way. And they're going to cover everything out that positive way.
Is this when we use like the infinity
It's all
sign?
real. It's all
Well,
real numbers.
in the future, we'll use the negative infinity to represent all real numbers. But y'all, in this section, all they do is they write it out. All real numbers. But y'all, later in the future, all real numbers will be something like this. So good job on knowing that. All right, so remember, we're going to get the opposite of A now. They want to know any x values for which f of x equals 1. And remember, they'll have the x equals down here. So y'all, what x values have a y value of a positive 1?
4 and 6.
So let's see. Perfect. 4 and 6.
But look, Mr. Eugene, I'm not gonna lie. The only reason why I know that is because I watched your video. So, but how did you get that? I don't know how you
Okay.
got that.
Because see, f of x equals 1, that means y equals 1. So I'm looking at this
Okay.
y-axis here. And remember,
Okay.
1 on the y-axis is right here, right?
Uh-huh.
So I'm looking at this, whatever touches that line going across this on my graph.
Okay.
Anything on that line has a y value of 1. So we seen this point, came down and said, oh, well, that x was 4. But it had this point also on that line.
Got
So
it.
came down and said, hey, that one was at 6.
Got it. Okay. Thank you.
Okay. Oh, y'all, watch this one. How about my range? So guess what? The range can't be all real numbers, can it? Because that range ain't touching nothing down here on this negative side. It seems like my range is all on this positive side. So on the range, I would put my y, because that's the variable for the range is the y variable. This bar means such that. So remember, that bar means such that. So what do I know about these y values?
They're
Y is greater than. Sorry.
Oh, you're on the right track. Say that.
Y is greater than or equal to 0.
Perfect. Because y'all, that's 0. Anything on that line is 0. And they go upwards, which is greater than. And you got to include that 4. So definitely you want y greater than or equal to 0. So y'all, not too bad. You just got to play with the graph. And remember, when I give it f of 2, if I got a number there, that's the x value. If I got f of x equals some number, I'm giving y'all the y value and you find me the x's. Hey, let me ask y'all something. I just got a chat. Someone said they can't hear me. Are y'all hearing me good?
Yes.
So yeah, it must be on your end on that hearing me.
They probably gonna have to log out there, log back in.
Okay, you can do that. I'll let you right back in. Alrighty. So y'all, that was the domain and range of a graph. But now, the big thing for this section is finding the domain of a function. All right, y'all. So the domain of a function is the set of all x values that produce a real number output when substituted for the variable. Y'all, let me let a few in real quick. All right, so Katie and Diamond both got knocked off.
No, I didn't. I'm still here, Mr. Eugene.
Okay.
Diamond's still here.
Okay, I got you. All right, so it produced a real number output when substituted for the variable. So y'all, let me tell you this. There's a lot of numbers that are real numbers. Real numbers could be positive numbers, negative numbers, zero. Real numbers can be fractions. Real numbers can be decimals. Okay? Two things that are not a real number. So y'all, let me ask you this. So this will be like a little review here. What does 2 divided by 0 equal?
Undefined.
2.
Oh, I heard it. Oh, what'd you just say? I heard it.
2.
Undefined.
Undefined. That way, if you try to do 2 divided by 0, that's why the calculators say error division by 0. So undefined. So I can't plug a number into a fraction that gives me a 0 on the bottom, because where do I plot undefined? There's nowhere to plot no undefined on a graph. So the first thing we're worried about when we're looking at the domains, fractions cannot have a 0 in the denominator. So if any numbers make that denominator 0, we got to exclude them from our domain. So in that case, our domain would be all real numbers except x cannot be whatever makes that happen. Now, the second thing we're going to worry about in future, not right now, but the second thing we're going to worry about deals with taking square roots of negative numbers. Can I take the square root of a -4 in the real world?
No.
No, because there's no way, like signs will make a -4. 2 times 2 is a +4. -2 times -2 is a +4. So we can't take the square root of a -4. So y'all, in the future, I'll show y'all that this will give me numbers like 2i. And y'all, guess what? That I means this is an imaginary number. So imaginary numbers are not real. And y'all, when I'm talking about the domain of a function, these are the only two things I am worried about. Do I have a fraction? Do I have a radical with a negative number under it, like a square root? Okay. Now, let me tell you this. In section 2.3, they only play with the fractions. They don't break out the radicals yet until, probably a few more chapters in the future, okay? So right now, if you have a fraction, you're going to find what number makes it equal 0 and exclude it from the domain. If you do not have a fraction, your domain will be all real numbers. So guess what? The rest of these problems, there's like 4 or 5 of them. They want us to find the domain of the functions. So look here, number 3, they got f of x equals 12 over x minus 7. So y'all guess what? I do have a fraction. So there might be a number that I can put in for that x that would make this equal 0. So usually what I'll do is I'll take the denominator. It's got to have a variable in it. So what I'll do is I'll set that x minus 7 equal to 0 so that I can see what number makes that true. Once I find that number, I'm kicking it out of my domain. Now, y'all, let me ask you this. There's not an exponent by this x out here, so what would y'all put?
Take 7 from both sides.
Well, no, I'm just asking you, what exponent would be on that x?
A 1.
A 1.
1.
Yeah. So if it ain't got an exponent, it's a 1. And the reason I'm telling you that, because the exponent tells me how many numbers I got to exclude. So since that exponent on the x is a 1, there's only one number. All right, so now you said what? Add 7 to both sides?
Yes.
So that gives us x equals a positive 7. So our domain will be the curvy parentheses. Our variable is x, such that x is a real number. And x cannot equal 7. Now, y'all be tricky. Watch Math Lab because it'll give you like A, B, C, D answers. And they might put less than and greater than stuff in here or just the equals. Pick the one that's got the not equals. So this means any real number works except for 7. All right, y'all, let's see what we do here. P of x equals 2x minus 5. What is my domain?
X is a real number.
Perfect. I don't have a fraction to worry about. X such that x is a real number. So then they say, hey, what about squared stuff? What if I had f of x equals x squared plus 2?
X is a real number.
X is a real number.
Because any number you give me, I can square it, add 2 to it, and I still have a real number. So x such that x is a real number. Oh, yeah, let me let y'all catch up, and then I'm going to turn my page. Oh, y'all, so numbers, huh?
Oh, I'm sorry. I was gonna say, so anything that isn't a fraction is gonna be a real number, correct?
Exactly.
Okay.
All right, but 6, guess what? They didn't want y'all to keep putting the same answer every time, right? So they're going to give you 2 over 3 minus 5x. So you knew they had to throw at least one more fraction at you. Do y'all remember, all I'm going to do is worry about the bottom here. So I'm just going to set that equal to 0. Now, y'all, you can move either one of these to the other side. But most people like to move the numbers first. So I'm just going to subtract 3 So that'll cancel, giving me my negative 5x equals negative 3. And then I'm going to divide both sides by the negative 5 to make this a 1x. So notice those cancel, giving me my 1x. So y'all, what does this thing reduce to?
It's gonna stay x equals 3 over
It
5.
stays that way.
Perfect, because those negatives cancel, okay? Remember, negative divided by negative is a positive 3/5. So we got x such that x is a real number. And x cannot equal, what do we get, a 3 over 5. No, they're not too bad. It's just fractions. I got to get to the bottom of them and see what's going to happen, okay? What about absolute value, though? What if I had the absolute value of x minus 9?
It's not a fraction.
All
It's a
real
real number.
numbers.
All real numbers. Perfect. Y'all get, and I think that's what this lesson's all about, is getting y'all to realize that undefined's the only stuff we're worried about, okay? All right, y'all, the last one in this section. R of x equals x to the third plus 12.
All real numbers.
X
Oh, I
is
think
a
I heard you. It was really low.
All
Did you-
real numbers.
X is
There
a
you
real
go.
number.
Well, x such that x is a real number. So y'all, that was 2.3. Not too bad. Just remember, there's only one thing we're worried about, and that's fractions. And I mean, fractions cover all real numbers. You just got to kick out whatever makes that bottom, okay? All right, y'all. So then we're going to hit, let me see my chat real quick. Okay, that sounds good. I'll let you in as soon as you get there. All right, y'all. So that brings on 2.4, and it's not too bad either. Let me fix my paper. It's starting to curl.
Can I say something real quick?
Yeah, I hear you.
So I was watching your other video and with the notes and everything,
Uh-huh.
and I just want to clarify that, like, I know the top doesn't matter, but like, even if there, because like you went to question or to problem 9 in your other notes, and you had a problem where it was f parentheses x equals x plus 1 over x minus 9. So with that, you still only just focus on the bottom, even.
So let me see. So what you're saying is, so say old homework, we had a 9, so it was what? F of x equal to x.
X plus 1
Uh-huh.
over x minus 9.
Yeah. So the reason I don't worry about the top, remember on the top, I can do
Yeah.
stuff like I can do 0 divided by 5.
Mhm.
0 divided by 5 would give me a 0. But what I can't do is have a number on top divided by 0. So if I was doing the domain on this one, all I would do is set that x minus 9 equal to 0. Solve that by adding my 9.
Yep.
And the only number I would kick out, I would have what? X is a real number, and x
Yeah.
cannot equal
9.
at 9. Because see, the top, you'd get what, a -1 or something?
Yeah.
Well, -1 minus 9 would give me a -10 on the bottom. So no matter what I put up here to get a 0, it would not make that bottom a 0, okay?
Yeah, I just wanted to clarify that even if there was a variable on top.
Yeah, so you're
it
only
doesn't
worried about
matter.
variables in the denominator.
Okay.
All right, y'all. So 2.4 is sort of fun if you like foiling and adding like terms and all that fun stuff. So 2.4 is the algebra of functions. Okay, so there's 4 operations we're going to have. So we're given f of x and g of x. So this is sort of, they're going to show me sort of like shorthand ways to write adding and subtracting and all that. And we'll show you what that really means. So your first operation, f plus g of x. So y'all, f plus g of x mainly means f of x plus g of x. So this is the sum of 2 functions equals the functions added together. And all you can do when you're adding is combine like terms. After dropping the parentheses. So I'll have each of my functions in parentheses when I start. I'll drop those parentheses, add like terms, be done. Now, the next operation would be f minus g of x. That'll equal my f function minus my g function. So what we do, we're going to drop parentheses. But we must distribute the subtraction through the second parentheses. And y'all ain't got my spell checker on it, so I mean, you know, parentheses is hard for me to spell. Hey, but after we drop parentheses, distribute that subtraction, we're then gonna combine like terms. So basically these two are the same, but like I said, the second parentheses, you're going to distribute that negative through there, okay? All right, so our next operation would be f times g of x. That's going to equal my f of x times my g of x. So on this one, you might be using the distributive property. You might be doing a little foiling, whatever multiplication they give us. Right, now my 4th operation is
Can you pull it down a little bit? I can't see.
pull a paper down.
Yeah.
Oh, is that
Oh,
better?
okay. Yeah, that's yeah.
Okay.
Thank you.
And our last operation will be f divided by g of x. That'll be f of x divided by g of x. But this is division. So y'all, since that division, what can g of x not equal?
0.
Cannot equal 0. Good job. All right, so we're just going to be playing with these 4 operations. So y'all, let's start on our first one. We're given f of x equals x squared plus 2. G of x is going to equal x plus 3. They want us to find f plus g of x. So they're giving me my 2 functions here, and they're telling me they want me to add these functions. So remember, we said f plus g of x equal my f of x plus my g of x. So here we go. F plus g of x. Now remember, when you first start, put these functions in parentheses to distinguish which one's which. So f was an x squared plus 2 plus my g of x, which is an x plus 3. So since we're adding, we can drop these parentheses and everything will come out the same sign as it was inside the parentheses. So that x was positive, and then that positive 3. So y'all, what can I do to this?
Combine like terms.
Yeah, I'm going to combine like terms, and looks like the only thing I got are these numbers. Remember, y'all cannot add these x's because the exponents don't match. Now, hey, on the final answer, they got to be in descending order. The highest exponent first, then the next exponent, and at the end will be these numbers. So bring down your x squared. Bring down that plus x. And then y'all, my like terms are just a 2 plus 3, which will give us a 5. At that point, we cannot go no further, so final answer. So adding is probably the easiest of the 4. All right, y'all, given f of x equals x squared minus 4, g of x equals, oh, they got an x minus 2. So y'all, for this one, they want us to find f times g of x. Then y'all, MathLab on this section, they'll put a dot here. But remember, I could just put FG right next to each other, couldn't I? Anytime the variables are next to each other, like I did up here, that also represents multiplication, okay? So here we go. F times G of x is going to equal my F, which was x squared minus 4, times my G, x minus 2. So remember, when these parentheses are backed up right next to each other, that also represents multiplication. So y'all, how are we going to multiply this? Well, we're going to do that little special word y'all learned in the past. We're going to FOIL this thing. Now, really, FOIL means you better multiply 4 times because there's 4 letters here. So F will be the first ones from each parentheses. So y'all, let me ask you this. This x squared times this x, what's that going to give us? And I'll even tell you a trick. Remember, since this x
To the third.
I
yeah,
was about to say, is it x cubed?
yeah, because this x has a 1 by it, and when we multiply variables times themselves, add those exponents. So that gave me an x to the third, because 2 plus 1 equals 3. All right, y'all, I'm going to take the x squared times the
Mr. Rathbun,
Yeah.
I have a quick question.
Uh-huh.
Can you explain why we can't add the exponents together when you're adding, but
Oh,
when
good.
you are multiplying, you can?
Only time you're going to change exponents is either multiplying or dividing.
Okay, okay.
When you're adding x squareds and x's, well, what if x squareds were quarters and x's were nickels? You couldn't write those. You couldn't
Right.
write this as 3/4, right?
Right.
Okay. So just remember, that's sort of that. I can multiply anything I want to in this world, but adding is really picky on looking the same. Even those exponents got to match, okay? All right, y'all. Now we shot this x2, this x squared times -2, which gave us a -2x squared. So that was the outermost terms. So we distributed the x squared through the second parentheses. Now we got to distribute this -4. So a -4 times the x would give me -4x. And y'all, finally, that -4 multiplies by the -2. So that's going to give me what? A +8. So just be careful on the signs. Positive times positive gave me a positive. Positive times that negative gave me a negative. Negative times a positive gave me a negative. And then that negative times that negative gave me a positive. So let me ask you this. Can this go further?
No.
No, y'all, because none of these exponents match. So we do not have any like terms. And we're happy it's in descending order, right? Got my x3 first, my x squared, then my x, and then my number. So we're happy when that happens. Sometimes they don't get nice and come in the right order.
Does it have to be in that order?
Yeah, MathLab will have you put these in descending order of those exponents, okay? So let me throw you a little curveball here. How about an f of x equals x squared minus 3? G of x is going to equal x minus 1. They want us to find g times g of x. So let me start out with my g times g of x. So I know I'm multiplying again, so let me make my two parentheses. So y'all, the question is, what's going in these two sets of parentheses?
Is it x minus 1?
And then how about this one?
X minus 1?
X minus 1. So they just wasted our time by putting that f of x there, didn't they?
Oh, it was like a curveball. Okay.
Yeah, they're throwing a curve because we got to go by what they're wanting. Sometimes they're going to give you extra stuff just to throw you a curveball there. But remember, g times g is a g function times a g function. So a little more foiling. So y'all, remember, this has got a 1 by it, and this one has a 1 by it. So that x times that x.
X squared.
X squared. Now, y'all, since these are the same two factors here, these will not cancel because these are not conjugate pairs. What's going to happen is the middle terms are going to double. Because watch this. X times -1 is a negative x. Now, remember, if I'm not writing a number in front of these variables, it's understood to be a 1 also, okay? All right, y'all, let's take this -1 here times x will give me -1x. And then finally, the -1 times that -1 is a +1. So notice this time your like terms are sitting here in the middle. Now they're both negative, so they can't cancel. So in descending order, I'm going to bring that x squared down first. All right, y'all, you got a -1x added to a -1x. That'll be what?
-2x.
-2x. And then at the end, we'll bring down our +1. Now, I'm going to show you a few examples from supporting a little bit, and we'll have some of those conjugate pairs. And I'll show you that the conjugate pairs are the ones where they cancel in the middle. All right, y'all, so we haven't done any subtraction yet, so let's play with some of that. So we're going to let f of x equal, oh, what do they got here? -18x plus 8. my g of x is going to equal x squared plus 5. On this one, they want me to find f of a -2 plus a g of -2. So y'all guess what? This time they're giving me a number to put in for these variables. Okay, so I know f of -2 plus g of -2 will equal this f equation. So remember, my f equation is -18 times x. Well, they want me to put a -2 in for that x. And then add my 8, close my parentheses. Then I'll have my plus, start my second parentheses, x squared. Well, g wants me to put a -2 in for that x. So I'm going to put my -2 in parentheses, square it, and then add 5. Now, these can be done on the calculator, but it's very, very important that the -2 gets its own set of parentheses in that calculator when you square it. If you don't have the -2 in its own set of parentheses, it will give you the wrong number. So y'all, order of operations, because I got numbers here, I'm going to follow the PEMDAS. Parentheses, I can work inside my parentheses. So I'm going to work inside the first parentheses, and look, multiplication happens before adding. So -18 times -2. Oh, what's that? A 36. Bring down my plus 8. I can do work in the second parentheses. Remember, exponent has priority here. So -2 squared will be a +4. And then bring down that 5. So now all I can do inside is do my adding. And since that's my last operation, I will drop my parentheses, okay? So 36 plus 8 gives me 44. Plus my 4 plus 5 gives me a 9. Now everybody's out of parentheses, so we'll add that 44 and 9. And that's what, 50?
53.
53, there you go. So they're really not that bad when you got numbers. Let's see. Oh, this one looks like division. So f of x is going to equal -11x plus 6. G of x is going to equal x squared plus 14. We're going to find f of a -5 divided by a g of -5. Now, y'all realize on the ones where they're giving me the same numbers here, instead of saying find f of -2 plus g of -2, I could have said find f plus g of -2. I could have used that shorthand lingo if I probably would have used the shorthand lingo, but MATLAB sort of kept them separated. All right, y'all, so here we go. F of -5 divided by g of -5. I'm going to make it look like a fraction. On top, f of -5. I'm just going to put a -5 in for that x. So I'll have -11 times -5 plus 6 over g of -5, which will be a -5 squared plus 14. Now, y'all, let me say this. If you did this on a calculator and you did the top divided by the bottom, put the top in parentheses and the bottom. Okay. If you don't make it look like a fraction in the calculator, you got to put parentheses around top and bottom so it knows what's the numerator and what's the denominator. Okay. All right. So order of operations on top, got to multiply first. So that negative 11 times negative 5 gives me a positive 55 plus 6. On the bottom, negative 5 squared is 25 plus 14. Okay, so remember, any number I square better come out positive at that point. All right, y'all, now, so let's see. 55 plus 6 is what, 61. 25 plus 14 gives us a 39. So the question, does it reduce? Now, if you want to check on the calculator whether this reduces, on my calculator, here's what I would do. I would do 61 divided by 39. That's going to give me a decimal. Now, to turn the decimal back into a fraction, I would hit math and then enter twice. When you hit math and enter twice, it'll turn that decimal back into a fraction in its reduced form. But y'all, guess what? 61's a prime number, so this thing will not reduce. So when you do this on the calculator, it will give you back that 61 over 39.
Mr. Eugene, do you know right off the top of your head on a TI-84 how to it's a way you can put the fraction in, like you see how you
Oh, let me show you that trick too. So
yeah, without like putting it without like putting the
parentheses and all that, yeah.
yeah, like it's a
So
way you
let
can
me-
make it just like a fraction. How do you do
Yeah,
it? I forgot.
let me pull my calculator up real quick and then we'll play with that. I'll show you both ways you can do it, but the one way, like I said, does require a little bit more parentheses. All right, y'all, so let's
Right.
go share my screen for my calculator. So if you want it to look like a fraction,
Mhm.
when you put it in, you would hit this green alpha button on the left side and then hit the Y equals. Option number 1, N over D, that means numerator, denominator. So when that's highlighted, you would hit enter. And on the screen, see how it gives me the fraction? So then let me see what I have on top. I had on top, I had a negative 11,
Negative, yeah.
and then times that negative 5. And it was what, plus 6?
Yeah.
Yeah, then when I arrow down to the bottom. Now, what's nice, if you actually put it in like a fraction, it will give me a reduced fraction for my answer. And I won't have to worry about all that decimal stuff, okay? So on the bottom, we still got to put that negative 5 in parentheses because we're squaring a negative number. I'll put my negative 5 in, square that, and then add my 14. So y'all watch this. I'm going to hit enter, and it'll give me my answer in fraction form of 61 over 39, which means that will not reduce. So, yeah, that's probably easier than showing you what I had on here. But yeah, anytime I want stuff to look like a fraction, I think we did that on graphing in station 2-1 when we did y equals, but I can't remember. Oh, you gotta love that calculator, right?
Yes, my teacher was a mastermind in high school, and I was like, okay, I can ask Mr. Eugene because I know he gonna know. I just couldn't remember. I was like, I remember her doing it, but I couldn't remember.
Oh yeah. All right, y'all, let's see. Oh, so my next one, f of x is going to equal negative 2x plus 3. G of x is going to equal x squared minus 4. We're going to find g minus f of x. So g minus f of x. This stuff's sort of fun though, right? Little more algebra. It's probably a little funner than doing that graphing with that picky graph, right? All right, y'all, let me make my 2 sets of parentheses, and they're going to be subtracted this time. Question number 1, what's going in the first parentheses?
X squared minus 4.
There you go. This one's backwards. They want the g minus the f, so good job. That'll be x squared minus 4. And that f was the negative 2x plus 3. Now, y'all remember on subtraction, I said you have to distribute this subtraction through the second parentheses. So basically, you're going to treat it like a -1 and multiply by this stuff, okay? There's nothing in front of the first parentheses, so we're going to drop that and make that an x squared minus 4. So y'all, what's going to happen when I subtract a negative 2x? So a negative times negative, there you go. That's going to be positive. And then what's next?
Would it be a -3?
It'd be a -3. So a negative times negative made that one positive. Negative times a positive made that one negative. Can I go further?
No, because there's no like terms. Right?
You can.
Yes, there
Oh,
is.
It'll
I'm
be
sorry.
-7.
Oh, there you go. Because you got these numbers sitting right out here. So there you go.
I forgot.
So descending order, I'll put my x squared first. I'd bring down my positive 2x. And then -4, -3, give me what, a -7. So yeah, y'all watch out, because don't let them switch the order on you, remember? Just like they did that GG while ago. They tried to throw you a little bit of curveballs. So the last curveball before we get to doing a little bit more domain stuff, we're going to have f of x equal x squared minus 12. G of x is going to equal 11 minus x. And y'all watch this. They want us to find f times g of a little n. So here we go. F times g of a little n. Now here's the one thing. MATLAB is picky. If it gives you a little n, you better put a little n in your answers. If it gives you a capital N, then you would have to use a capital N. MATLAB is very picky on capital, lowercase numbers. So this is multiplication. So we're going to put our parentheses right up next to each other. All right, what's going in the first parentheses?
11 minus x.
Oh, what'd you just say?
Is it x squared
Sorry,
minus
x
12?
squared minus 12, I'm sorry.
N squared. There you go. Because remember, they're telling me now that this n has to go in for these variables.
Oh, okay.
So make that an n squared minus 12, which means the second parentheses is what?
Is it
11
x minus n?
n.
I mean, yeah, 11 minus n. I don't know what.
There you go. I mean, the n is just like an x when I multiply and do all that fun stuff. But yeah, MATLAB, if they give me n here, your answer better have that n. So y'all, let's foil this. The n squared times 11 is 11 n squared. But how about this n squared times this n? And that's going to be
Negative
negative, right?
two.
That's positive and a negative. So a negative
N3.
N3, there you go. So once again, we treat the N like a 1 and we add exponents. All right, y'all, negative 12 times 11 will be what, a negative?
121.
Oh, that's 11 times 11. Now, y'all from Arkansas.
Negative
Y'all-
132.
132, there you go. I know y'all can at least go to 12 by 12 in Arkansas because that's where I went to school and we always did at least up to 12 times 12, right? All right, y'all, what's left? That negative 12 times that negative N is a positive 12N. So the question of the day, can I go any further?
No.
No.
Oh, y'all remember I said there's one thing you better do to that thing.
I'll put it in order.
Put it in
Descending
order.
order.
There you go. So remember, you definitely want descending order. So now be careful. You got to move the sign also. That's a negative N3. So we need a negative N3 first. The 11N squared is positive, so we'll add 11N squared. Next will be the N. It's a positive 12N. And then at the end will be our negative 132.
Can you explain the N again?
Explain
Oh,
what,
why you put the N like right up in the beginning?
right up here.
Yeah.
So see right here, they're telling me, hey, we want to multiply F times G, but instead of giving me an X here or a number like earlier, they put an N here. So what they want you to do with that N is put it in for that X and put it in for that X on that G. So all I did was replace that with an N and then this X with an N also. So if I put a R here, this would be R squared minus 12, 11 minus R. Whatever letter they put here, that's what you're going to plug into these functions, okay?
Okay.
You'll get used to it. We do enough foiling in this class. All right, y'all, so let's see. So now we're going to play with a little domain stuff. See if y'all remember what we learned about the domain in section 3. All right, are y'all able to see the top still? Am I up close enough?
Yes.
Okay,
Yeah, it's
so
okay.
for the functions, F and G, we're going to determine the domain of the sum. So sum was our adding, difference was our subtraction, and the product. So for my first one, f of x equals x squared. G of x is going to equal 4x minus 7. Now notice, I only got to do my adding, subtracting, and multiplication. So the sum would be f plus g of x. So f was an x squared, so I'm going to come put my x squared in. And we're going to add that to the g, which is a 4x minus 7. So notice they didn't give me any numbers to put in for my x's this time, so they're going to stay x's. So the question of the day, What is the domain of these two functions being added? So what was the golden rule a while ago when we did those domains?
All real numbers.
Because there's not a...
I mean,
Oh, you're perfect. But we picked all real
it's
numbers
not.
because there's not a fraction. Good job. So there's not a fraction. So x such that x is a real number. So subtraction would be f minus g of x equals my x squared function minus my g of x function. So y'all, any guesses on that domain?
All real numbers.
There you go. There's
There's
not
no
a function. There's not a fraction. Let's see. What was next? We had a little bit of multiplication. F times g of x will equal my x squared times my 4x minus 7. Domain.
Real numbers, because there's no fraction.
And y'all, I think they really want y'all to realize that you're adding, subtracting, and multiplication. They usually have the same domain. Whatever one of them three has, the other two usually has also. Because there's no way to make anything into fractions by adding, subtracting, or multiplying, okay? So guess what? They don't want you to be able to put that answer every single time. So for this one, for F and G, we're going to determine the domain. Of the sum, difference, and product. But y'all watch this. F of x is now going to equal 1 over x minus 3. G of x is going to equal 7x to the third. So guess what? They going to give you a fraction on the second one, okay? So let's start with our adding. F plus g of x will equal my f, which is 1 over x minus 3, plus my g, which is 7x to the third. So we got a fraction. So we might have a number we're worried about on this one. So remember, if we had a fraction, we set that bottom, x minus 3, set that thing equal to 0 because that'll give us the number that makes this equal 0, and we will kick that number out of our domain. So we're going to add 3 to this. So that means, since I got x equals 3, boom, 3 minus 3 would make that a 0. So we're kicking it out of our domain. So x such that x is a real number. And x cannot equal a positive 3. So remember, any other real number will work. I can put a 0 here. 1 divided by negative 3 works. I could put decimals there. That would work. I can put fractions down there. That would work. Only thing that would make that undefined is a 3. Right, y'all. F minus g of x will equal my 1 over x minus 3 minus my 7x to the third. So any guesses on the domain?
X minus, I mean, you talking about the math part? Like say x minus 3 to 0, right?
Oh, well, hell, you done did that up here.
Oh,
You know it's
Oh.
3 right here, right? So what's going down here? X such
Is there
that,
one? Oh no.
I think I heard something say X is a real number. And X still cannot equal a positive 3. And if I put a 3 in here, that gives me undefined. And undefined minus 7x3 is not defined. So we got to kick out that 3.
So is that the answer? Because for the F plus G, the one right above it,
Uh-huh.
do we not put anything for the 7x squared then?
Oh, no, this thing can equal anything. There's no way to get a fraction on that.
So
I
we
can-
just, that's not part of the answer?
No, because the
Okay.
only number that'll keep me from being able to add this stuff is a
It's the
3 right
fraction.
here.
Okay.
See, I can put a 3 over here, cube it. That'd give me 27 times 7. Any other real number you give me, there's nothing excluding this part. I can throw anything here and cube it. But what I can't do is divide that 1 by anything that equals 0, okay?
So you're saying if we have a fraction and it equals a real number, you can't proceed with the rest of the equation, right?
Well,
That's what I'm trying to get at.
okay,
Yeah.
so watch this. Let me show y'all a trick here. Let me share that calculator. So I'm going to make this look like a fraction by hitting y alpha equals. Alpha y equals and hit enter. So notice on the top, I had a 1. On the bottom, I had an x minus 3. So we said we got to kick out that 3. So let me do 3 minus 3 down there. Whoops, let me backspace. Let me use my calculator. I was using my keyboard. So I said make that a 3, right? So bang it back up. So 3 minus 3. Arrow out of that. And we were what? Subtracting 7x to the third. So that would be 7. My x was a 3, right? And then I'm going to make that a third power. So if x was 3, this was how it would look. But y'all watch when I hit enter. It says quit or go to because I got a calculation contains division by 0. So let me go down here to where it says go to and hit enter. So what's it saying? It says, hey, you can't subtract this because this first part equaled undefined. Any other number you give me for put in for these x's, it'll work. So I don't focus on the non-fractions. I only focus on the fractions, okay? All right, let me go back to my pad. So, yeah, you don't have to worry about this part because it wasn't a fraction. So like I said, any number you put in for this x and this x other than 3 would work. So let's do this multiplication. You got 1 over x minus 3 times 7x to the third. What is my domain? Well, y'all, I ain't worried about this x to the third. The only thing I'm worried about is this fraction again. And there's only one number that x cannot equal. And we said up here that would be a 3. So this is,
X is a real number and X is not greater than 3.
there you go. Are y'all realizing that all 3 of these have the same answer again? They all had the
Yes.
same answer here. They all have the same answer here. These
Yes.
3 operations will always have the same answer, okay? Now, division's a little different. So, let y'all write that while I get a drink, and then we'll flip this over. All right, so we got one more for division. You know, they wanted to give you an actual division on here. So, for F and G, determine the domain of F divided by G of X. F of X is going to equal 4x minus 5. G of X is, I'm trying to write my whole problem out. G of X is equal to 5x minus 35. All right, so F of X is 4x minus 5. G of X is 5x minus 35. So my F divided by G of X, I'm going to put my F on top, which is 4x minus 5, over my G, which is 5x minus 35. Now, y'all, we'll solve this, and then I'm going to show you what happens on a graph on this one, okay? So, what would we do to find our domain?
Divide that 5 into 35.
So this bottom here?
Yes.
And we're going to set it equal to
7.
Oh, 0. Oh, well, you got the right answer. Perfect. So I'm going to show them how to solve and get that 7 like you did. So you're going to add 35 to both sides. Get that 5x by itself. And then turn 5x into 1x by dividing by 5. So we get x equals 7, which means 7 will make this a 0 down here. So the domain will be x such that x is a real number. And x cannot equal 7. So y'all remember this number because I'm about to show y'all what this looks like on the graph, okay? And let's find out what happens where x is 7 on this. We're going to look at the table and see what happens at 7. So let me share that calculator. So I'm going to go to y equals. Now remember, I'm going to make that a fraction by hitting alpha y equals and enter. So y'all on top, we had a 4x minus 5. So 4x minus 5. On bottom, I had 5x minus 35. Now, I'll show you the graph, but the graph, what happens when you got a place that's undefined? It makes a hole in the graph, but y'all on the graph, you ain't going to see the hole. But you see over here where this 7 is on the graph, go over to the x-axis at about 7. You see how one part's going down and the other part's going up? That's because that graph cannot cross over that X value of 7 because it's undefined there. So let me show you this little table. Hit second graph. Now we'll learn about those later in life. We call that an asymptote, where it does that upwards and downwards part. So let me start my graph up here, just show you these negative numbers. Well, look, I'm getting fractions, but all these negative numbers are real numbers, right? They're just fractions. And you can go as far as you want. You'll still get an answer going to the negative side. So let's go back down to the positive side. So 0 works, 1 works, 2 works. All these numbers are working. Oh, look what happens at 7, y'all. It says error. That's because when you put the 7 in for the x's, that bottom equals 0. Now, as I keep going, I can go all the way to infinity. I'm going to get an answer no matter where I go. The only place that I couldn't go and graph this was at 7. At 7, I get an error, which means, hey, we tried to divide by 0, okay? But notice, anywhere else, you can scroll that thing forever, and you won't get another one of them error messages. You'll just get fractions or whole numbers, okay?
Mr. Eugene, quick question. When you put that fraction in the y1, y equals, how did you put that variable, the x variable on there again with your calculator?
So watch this button light up that I got.
Mm-hmm.
In the middle by the alpha button, you see that red button that just lit up?
Yep, I see it right here.
I hit that. That's the quickest way to get an X. Otherwise, you would have to hit the alpha button and look for the green X down here. And that'd be down here by the 1 almost on above that STO button.
Okay.
But y'all, that way is longer. This button right here, that I'm punching right there, that'll put that X quick.
How did you get to the different answers? Like
When I was doing
when you had that T chart and you had like the answer, how did you get to that?
If you want to see the graph, you hit the graph button. You see right above it, it has a blue table.
Oh, okay.
So to hit the blue, so the button does what it says, but if you look above it, anything in blue, you hit that second blue button that's red now. And then I hit that graph. And since I hit the blue button, it pulls up the table. If you want those letters that are above them, the letters are green. So to make it punch those, you would hit that alpha button and then the button that had your letter. So the stuff in blue, you hit the blue second, and stuff in green, you get it by hitting the alpha.
When I hit the graph, it didn't show me a graph though. It said error.
Okay, so what's the error saying?
Check values in window.
Okay, so watch this. Hit this zoom button that I'm hitting. I'm hitting the zoom button.
Okay.
Go down to standard number 6. That'll make that window a 10 by 10 window and hit enter. Did that fix you?
Oh, yeah. Okay.
Okay. What was happening, your window must have had the numbers off and it wasn't doing -10 to 10 type stuff. But yeah.
How can I get it to -10? Just keep doing that? Just zoom 6?
Or you see this button that says window by the y equals?
Yes.
If I hit enter on it, you see it's got X minimum.
Yes.
Is at -10. If you want any other values, you would put in like -5 or whatever you want. Then you would arrow down and put your X max. But if you hit that standard button, it does this 10 by 10 stuff automatically.
Okay.
Now later on, when we get into the future, some of our windows have to be set different than -10 to 10. So to reset them by what the math lab's giving us, we'll hit that window button, okay? All righty, y'all. So y'all support homework will be going over. So let me just show y'all a few out of the support for 2.4. So that y'all sort of know what's going on with these things. So I have a D plus parentheses 31D minus 83. So these support ones were sort of getting you ready for the operations today. So the first thing you got to do is drop parentheses. And since these are after addition, I can drop the parentheses and keep everything the same. So I would bring down my D plus my positive 31D minus my 83. Now, can you go further on that?
Yes.
Yes, the 30,
Uh-huh. Remember, that's like a
32.
because that's like a 1D. So 1 and 31 gave you 32D. And then bring down your
32D.
minus 83. So let's see what we'd do here. 9D minus 8 minus parentheses 5 minus 6D. So this 9D has nothing on it, so I'm bringing it down. I'm going to bring down this minus 8. But y'all, what I'm worried about are what are the two next numbers I'm putting?
-5 and then 60.
Yeah, so negative times positive made that 5 negative. Perfect. And then the negative times the negative made that a positive 6D. And guess what? We can go further. Looks like, ooh, we got a lot of like terms on this. And so what's my final answer?
15D minus 13.
15D minus 13. So we added our D's, added our numbers, and we were done. -6U minus parentheses -2V plus 6 close parentheses plus 14U plus 9. So this one they said, hell, we'll subtract one of the parentheses and we'll add the other. So we're going to bring the -6U down. All right, then I'll let y'all finish me out. I got about, what, 4 more things to put down. So what are they going to be?
2V minus 6 plus
2V
14U plus
minus
9.
6. So you distributed that. And then you said plus my 14U
Plus 9.
plus 9. So really the only thing you're worried about, notice, is that subtraction getting distributed through there, okay? Well, y'all, let's see what like terms. Let me start with these U's. So these U's will add. So -6 and 14 will be an 8U.
And then you're gonna bring the 2 down.
And then bring that 2V down. Oh, and look at this. -6, positive 9.
Plus 3.
And positive 3. Good job. All right, y'all, then they're going to play with a little bit of multiplying to get you used to all that multiplying we did. So -4 times 7A plus 8B. So when you got a negative in front of the number, this whole thing gets distributed. So how about a -4 times a 7A?
-28.
-28A.
How about a -4 times a 8B?
-32B.
Can you go further?
Nope, there's no
No.
like terms.
Good job. No like terms. 2x times y minus z minus w.
It's going to be 2xy minus 2xz minus 2xw because you distributing everything in parentheses.
Perfect. You distribute that whole 2x through everything. And you did good because that was a positive times a positive made a positive. Positive times a negative made a negative. Positive times a negative made a negative. And remember, you can't change exponents on these because you never had the same variable being multiplied. All right, y'all. 9b to the third times 2b. What's that giving you?
Is it 18b to the fourth?
Yeah, because remember, that's a 1 by that b. 9 times 2 is 18. On my b's, I had 3 plus 1, which gave us a 4. All right, so say that with more confidence, okay? 6g times negative 4g squared h to the 4th. So notice this will be one big number because there's no pluses and minuses in between these variables. So 6 times negative 4 is a
Negative 24g to the third.
Well, how about the g times the g squared?
G to the third, right?
And then what's coming down?
H to the fourth.
H to the 4th. So the H couldn't change because there wasn't an H out here. So, but you write this as one big product and you're done. So let me do one more with y'all and then I will release y'all. These are conjugate pairs. These parentheses look the same other than the adding and the subtracting. So these are called conjugate pairs. So watch what happens when I foil these. So y'all, what is a 5b times a 5b?
25b squared.
All right, 5b times a negative 3d.
Negative 15 BD.
BD.
Now, usually when I got different variables, I try to keep them in alphabetical order, okay? But a BD is the same thing as a DB, okay? All right, y'all, here we go. 3D times 5B.
15 BD.
And then finally, a 3D times a negative 3D.
Negative 9d squared.
Perfect. But y'all notice, since these were conjugate pairs, what happens to this stuff in the middle?
They equal
You
out.
add it together.
But what's negative 15 and 15 give you?
It's 0.
Yeah.
So we say that those things, what, cancel out? So notice my final answer will be that 25b squared
Minus 9D squared.
Minus 9D
minus
squared.
9d squared. So there's a couple more you got to foil, but we done so much foiling while ago that you'll get used to that. I wanted to make sure I at least showed you. So if you notice, you got conjugate pairs when you start these. You can shortcut them. You can do 5b times 5b. That'll give you the 25b squared. And then you can do the last one times the last one, and that'll give you the negative 9d. You don't have to do the inners and outers because they're always going to cancel out in the middle. That's one of the nice properties about conjugate pairs. And y'all, have y'all ever heard this type of answer? 25b squared minus 9d squared? Conjugate pairs always foil into what we call the difference of perfect squares. Right? Square root of 25 is 5. Square root of 9 would be 3. So these are always perfect squares when you're done, and they're always subtracted, okay? All righty, so y'all look at that. We did 2.3, 2.4, And then we looked at a lot of that support for 2.4. So let me stop my share for a second so I can knock that video out.